Welcome back. We are looking at the second part of section 17A in the textbook. And in particular, we're basically just reviewing what we've learned about kinematics and then applying it to some situations. Kinematics is the study of pure motion, and we're talking about displacement of an object. Okay, now remember, displacement is a position. Okay, it could be positive or it could be negative. If it's positive, it will be on the right-hand side of the origin. If it's negative, it will be on the left-hand side of the origin. If it's equal to 0, it will be at the origin. We call this S of t often. Okay, so displacement, where an object is. If we differentiate this, function, we end up with a velocity function, v of t, or derivative s of t. If we differentiate this, we end up with an acceleration function, or the derivative of the velocity, or the second derivative of the displacement. Looking at this diagram is going to, and memorizing that will really help us in solving problems. Now, in sign interpretation, so we can use sign diagrams to interpret three big ideas about motion. Where the object, we'll call it P, is located relative to the origin. So where is it in relation to the origin? We can interpret the direction of motion and where the change in direction occurs. Where a change in direction occurs, if there is a change in direction. And we can interpret when the object's velocity is increasing or decreasing. And these are all important concepts or links to understand about kinematics. These charts on page 418 are invaluable. So, signs of S of t. Let's just take a look at here what we're seeing. Signs of S of t. If S of t equals 0, then P is at the origin. If it's greater than 0, P is located to the right of the origin. If it's less than 0, P is located to the left of the origin. We've already been through this. Signs of velocity, Vt. If Vt is 0, then that object is instantaneously at rest. Okay, so this may mean it's changing direction, okay, or it may mean it's stopped. If v of t is greater than 0, P is moving to the right. If v of t is less than 0 or negative, then the object is moving to the left. Signs of A of t. If A of t is greater than 0, the velocity is increasing. If it's less than 0, negative, then the velocity is decreasing, slowing down. If it's equal to 0, the velocity may be a maximum, it may be a minimum, or it may possibly be constant. Okay, so no change in velocity. Okay, so no change in velocity. Maximum, minimum, or constant. Good idea to mark these in your notes, keep them, and have them for memorizing. Here's also a useful table. Just like it says, useful table. Phrase used in a question. If we're talking about initial conditions, we're talking that time is 0. Initial conditions. If we're talking about at the origin, then we're talking about displacement is 0. S is 0. If we're talking about stationary, then we're talking about the velocity is 0. Okay, so it's not moving at that instantaneous point in time. If we're talking reverses, the velocity is also 0. So it's changing. Okay, changing from going forward to in reverse, forward to backwards. So at that, there has to be some instantaneous point in time where the velocity is 0. If we're talking about a maximum or a minimum displacement, the velocity is also 0. Talking about a constant velocity, the acceleration is 0. And talking about a maximum or minimum velocity, the acceleration is also 0. Okay, very good chart to have handy. Okay, let's talk a minute about speed. Yeah, you can read about it here. I'm also going to write a note about it. A note about velocity and speed. They are similar yet different. And those of you that take physics, I'm sure know about this already. So velocity has magnitude and direction. Magnitude means size, how big it is. Okay, velocity has magnitude and direction. When we see velocity written, it looks the same as speed, but if it has a plus sign there, that means the direction. If it has a negative sign there, that means the direction. If it has no sign, of course, that means it's positive. So it still has direction, okay, if it's a velocity. So how fast is represented by the number that's given, and the direction is represented by the sign that's given, positive or negative. Okay, speed on the other hand has only magnitude, does not have direction. So there's no sign represented, therefore it's just how fast, which is represented by the number. Therefore, the speed at any instant in time is the magnitude of the velocity. So discounting the sign that is associated with velocity, that would be the speed. Okay, so that's why these two terms often get mixed up in everyday use. But velocity has direction, in other words, a sign, positive, negative with it. Speed is just the number. There's no sign. Now, they appear to be the same often. If velocity is positive, then those two numbers will appear to be the same. So to determine if speed is increasing or decreasing, we use the sign test. This test is very important. If v of t and a of t, so velocity and acceleration, are the same, have the same sign, then speed is increasing. If v of t and a of t have opposite signs, I guess up here I could have said have the same sign. Have the same sign. Okay, would be better to say. So if v of t and a of t have opposite signs, then the speed is decreasing.